Hey guys, welcome back to the channel. If you are new here, my name is Alex, and the video that you are about to see is one of the most requested ones on my whole channel. Previously, I've done a video to show you how you can generate time-based one-time passwords using Google Authenticator and then expose them as part of a QR code so you could get them in your app and validate that they are generating the same code that the backend would generate. And a lot of you asked how to do this together with Spring Security, and I even suggested to make a follow-up video to this. And it's been a while, but here is the video. So I will show you an approach for setting up multi-factor authentication using time-based one-time passwords that plays nicely with Spring Security. And as usual, at this point, whenever I do security-related videos, a word of warning. I'm gonna disable some sensible defaults today, and we'll show you something that serves as a proof of concept. So you shouldn't blindly copy this over and run it in production. Make sure you understand the implications of what you're doing. And with that said, let's code. Okay, we are at my favorite place, the IDE. As you can see, we're starting out with Spring Boot 3.1.2. And I have two things that I brought in here, which is Spring Boot Starter Security and Spring Boot Starter Web. I will add another dependency, which is this one. And that's the same dependency that I've used in the previous video. And that's just used to generate a shared secret, generate a time-based one-time password. All that functionality is delegated to that library. Cool, so let's get started. We just go to our application, which sits here. And if I have the Spring Boot Starter Security on a class path, there is a default configuration that is applied already. So if I start the application right now, you will see that Spring Security is generating a default password over here, which is just a UUID, and the user is user. So we could use that to authenticate, but there's nothing to authenticate against it yet. So this is why we just start with our first controller that we can secure. So let me minimize that. And then we go ahead and we create a class which is called user controller. It's really simple. It's just a REST controller. There we go. Where is it? Import this one. And we say it has the request mapping. So this is the base path that we're going to use. It's users, and then there will be just one get mapping. Get mapping for me. What we're going to do is we ask Spring to provide us with the principal. Where is it? There we go. And we just return it. It's pretty simple. Principal equals principal. So once I'm authenticated, Spring Security has a principal. That principal will be injected here into that function. And then I just return it back to the client. And in reality, again, you should never do this because that's the naked principal that I'm publishing here. That also contains some sensible defaults like or not defaults, but sensible information like the password, even if it's hashed. You don't want to expose that. So I'm just doing this here again for illustrative purpose. This will work at this point because the endpoint is not yet secured. We have to provide a security config for this to work. So let's go here and now we say new class. This is the security configuration. And let me just annotate this with configuration. And I'm also enable web security and say debug equals true. We're going to use that later on when we want to see the chain of filters. And I'm doing a brief recap of how Spring Security works in just a second once we have that security config in place. So I'm supplementing a new bean, which is the actual security filter chain. So I just call it chain. It expects the HTTP security and it returns the security filter chain. So I could just say HTTP build here, and that would do. We want to authorize certain requests, so I'm going to go with HTTP and then authorize HTTP requests. And I say any request should be authenticated. I also want to configure basic authentication. So I'm going to go with HTTP basic and customizer. This one's correct. And then we have customizer. Like this. Okay, so we have the customizer with defaults. And I'm also changing the session management because I want to make sure that we have stateless sessions here. So I can say it session creation policy, and then session creation policy stateless. So let's restart the application and see if this works. So it wants me again that security debugging is enabled, which I did here with the enable web security debug equals true. And I know that should also not go into production, by the way. So let me grab the randomly generated password here. And then we can just go, I do this in a browser. If we get to the other stuff in a second. If we go here, go to users, me, it's asking me for my user, and I can just supplement the details here. And you can see I'm authenticated is true. And this is the principal password null, so that has not been exposed. Username is user. I don't have any authorities apparently. And yeah, so that means authentication works. Now, before we continue down this path, I want to briefly recap how Spring Security works. I prepared those little graphics over here. And let's quickly go over the details, and then I will show you how our current solution fits into this architecture. So all authentication usually is handled by authentication filters. So that means a request is intercepted, delegated to a filter, and then a lot of stuff happens under the hood. So we have usually some sort of authentication filter that is receiving the request. It then usually provides some sort of authentication object and delegates that to an authentication manager. And the authentication manager is really just a single interface for all these filters. But what the authentication manager actually does is it maintains a collection of these authentication providers, and they implement the actual authentication logic. So that means the authentication manager just checks, okay, I got some sort of authentication like a username and password, a JWT token, or a time-based one-time password, as we will see. And then it will just look through all the authentication providers that it knows and ask them, can you handle that kind of authentication? And if one of them provides confirmation for that, that provider will just handle the actual authentication. And usually, especially for the username password authentication, you will also need the user details service and the password encoder, because the first is used to just fetch the user details and then validate that the password matches using the password encoder. So let's see how we want to use the MFA authentication on top of that. So this is the second graphic. As you can see, what I want to do is, and what we started doing already, is using basic authentication. So this means we can authenticate initially with an existing user. And this is handled in Spring using the basic authentication filter. And then there is a DAO authentication provider that's using the user service. This is something that we will implement. And we're using the bcrypt password encoder, which is the one that I use by default. And one thing that I forgot to mention is the security context. This is where authentication information is stored. So once we go down here, authenticate a request, and then go back up if everything succeeds, the authentication object is stored in a security context. And this is something that we actually rely upon, because I want users to authenticate first using the basic authentication. And after we have a successful authentication, we provide a second filter that sits directly behind the basic authentication filter. And that will just make sure that the user is already authenticated. And only if that's the case, we check if the user requires MFA, because I want to keep this purely optional. I want to make sure that users can enable MFA or disable it. And only if they have enabled it successfully, they are required to provide a code. But in order for me to check this, I need to make sure that the user has been authenticated before. And I don't want to build all of that authentication logic myself. Rather, I rely on the basic authentication to finish successfully before we actually start with our authentication. And you can see the names here already. I called this the OTP auth filter, OTP for one-time password. Then we are delegating to the very same authentication manager, but we register a new authentication provider that actually implements the logic for authenticating a user based on an MFA code they have to provide. So let's get back to the code. Back in the IDE, the next thing that I want to do, I stop the application, minimize that, I don't need this, is I want to model a one password device. Because as you may know, there are multiple means of password devices. There can be Google Authenticator, which is software running on your phone. And then you have these YubiKeys, which are hardware devices. So I want to just kind of abstract that away. So this is why I provide an interface for all of that. Pick interface, and I call this the one-time password device. So what makes a one-time password device in our book? So it usually has a UUID. Just want to make sure that across all the devices, there's a globally unique identifier. So these can be stored in a database. I'm storing everything in memory today, but with that setup, it should be easy to attach it to a database. Then a device should have a name. and that is user assigned. That's just for the user to provide the name so they can recognize the device, especially if they have multiple, for example, iPhone 1, iPhone 2, they know which one to use, right? So this is why they are allowed to attach a name. Then I want to provide a function which allows us to calculate a secret. And you've seen this in my previous video. Each one-time password has a shared secret. That shared secret is known to the server and it's exposed usually only once to the client as part of a QR code. You can also enter it manually, but QR code is usually more convenient. So we need a way to calculate that secret. Then I want to have a function that can confirm an existing code, and it tells us whether that is confirmed or not. Then I have a function for just asking whether a device has been confirmed. Again, the idea here is to make this purely optional. If I add a new device, it will be generated on the backend with the secret, but that doesn't mean that I have scanned the secret or know the code already. So a device will be unconfirmed the moment it is added, and only after I have provided a valid code for the first time, we confirm the device, because then we know that the user has successfully imported the secret. So final thing is a check, which just says accepts code string. That's similar to the confirm function actually. So now we also provide the first implementation for that. And what I'm going to do is I do this in here just to keep things clean. I call this authentication device. That should be it. So we have to override things. Let me just make sure. So this is implementing one-time password device. I call this Google authentication device. Let me actually call it Google authenticator device. So we override the UUID. We can just generate that here. You can say random UUID. So there's this missing. Then we have the name that's provided. And for secret, what I'm going to do is I also generate this here. And here's where we use the existing Google Authenticator from the library that we're using. And we say create random secret. So that's generated here, and a device is unconfirmed the moment it's generated. It has to be confirmed first. So then the Google Authenticator device needs an instance of the Google Authenticator. So Authenticator like this is a Google Authenticator, and that's initialized with the secret that we created up here. And next up is implementing the methods. So confirm. That looks good already. GitHub Copilot did a little bit of work for me here. So that's just returning whether it's confirmed. Accepts actually says the authenticator that we have here. We generate a code and we make sure whatever code we are generating in the backend matches the code that has been supplied as part of that function call. So I need to clean up a little bit here. That doesn't belong here. Just copy. All right, secret is secret, and the confirm function, I'll change that slightly. So I'm gonna say if the device accepts the code, we just say it's confirmed, and we just return confirmed like this. Yeah, so this gives an error because confirmed as a val. There needs to be a var because it can be changed, right? So we have to make it mutable. And that wraps up the implementation for the Google Authenticator device. You can see we delegate to the actual Google Authenticator from the library. We expose the secret, we can confirm codes, check whether they are confirmed and whether the device accepts a particular code. The next thing that we have to do is add a new user that can actually hold such a device. So I'm going to create a user, and we call this token user. So a token user needs to implement user details because again, we're using Spring Security, and user details is the interface that kind of represents a user in that framework. And now we are actually required to implement all these members here. So get authorities, get password, get username, all of that. And that's a lot of work. But since we're using Kotlin, we can do a little neat trick here. We can use delegation. So what I'm going to do is I say, okay, a token user is just decorating an existing user. So I say, okay, I need some existing user details. And then what I can do is say, okay, this interface user details is provided by that property that I've been given here. So now I'm not required to implement all of that because I'm just saying that interface is fulfilled by the user details that I got, which is obviously the case. So I can now selectively override only the things that I'm interested in. So what I'm going to do is have a one-time password device because this is different from the original user details. So that can be null because a user may not have it. And again, I'm just making sure that the user has at most one-time password device, but it's also possible to just change the implementation so that a user can have multiple devices. I'm gonna override the toString method to return the details username. So that should be easier to read. And I want a helper function that tells me whether a user requires MFA or not. So I'm gonna say requires MFA, that's Boolean. So a user only is required to provide MFA codes if they have a device and it's confirmed. So, and I have to do this here, equals true. That looks like boilerplate code, but actually device may be null. So that whole expression may be null. So it cannot be automatically cast to Boolean then. So I have to make sure that whatever is on the left-hand side equals true. So then that all works. And only if a user has a device and it's confirmed, we say, okay, now that user actually requires MFA to authenticate. So the next thing that we need is an implementation of the user detailed service, because as you remember the image, a user detailed service implementation is needed to look up users. So what we're gonna do is call this just user service. I'll make this service stereotype. And I'm going to say, okay, this is an implementation of the user details service. So now we have to implement just actually one function, which is load user by username. And I first want to start with the storage of the users. Again, I'm doing everything in memory. So I maintain a map of users, which is a mutable map of. So we want to have the username actually mapping to a token user. That's what we're going to do. So these are the users. And then I want to just also provide a helper function, which is easier to use going forward. I call this just by username. It works pretty much the same. We expect a username and we return a token user. And that is the user. That's pretty much it already. So GitHub Copilot did the work here. So I'm looking up the in-memory users over here based on username. That may be null if we don't know the user yet. If that is the case, we just throw an illegal argument exception that we don't know the user. So now what I can do here is simply make this a little bit shorter. It's expecting the user details, and I'm just saying by username. We'll make sure that this is not null. This should be a safe assumption. If not, call me out for it. And this is parsed, right? Because the token user implements user details, so we can return the user details here. Again, this is just a convenience function that we can use later on. So while we are in this service, I also want to provide a function to register a new user. Oh, it's listening, see? So we're gonna say we need a username, of course, and we need a password. Password. Oh, geez, I made a mistake here. So let's go back. Let's try this again. Password. And that's a string. And I can use the builder on the user that's provided by Spring Security. So I can say user equals user with username starts the builder. So I'm providing the username. So now we have to provide password. So, and this is wrong what I'm doing here. I just finished the code and tell you why. Authorities, we just provide one, we call it root. It doesn't really matter in our use case. You can do whatever you want here. I say account expired is false, and account, let's just disable it, I think. Disabled is false. Should be the defaults anyway, but I just built them. We build the user, and then we make sure that users has a new user, right? So we create a new token user. These are the user details here that we're delegating to. If you remember our delegation here, so we expect the existing user details. And then in the user service, so we just use them, stuff them into the token user, and then store the token user in memory. The thing that's wrong here is password, because that password needs to be encoded, and we need to provide a password encoder, right? So what I usually will do is say password encoder, please give us the password encoder, because what we need to do is say encoder, encode password. But now it tells us, I don't know, a bean of type password encoder, which is weird. Why is that? The reason is that we now supplemented our own user details service to the Spring context, and that means some defaults are disabled, and one of them is the password encoder. So we have to go to the security config and now provide our own password encoder. So I just call this encoder and it's interface password encoder, and it's the bcrypt password encoder that I usually gonna use. So I'm implementing that interface. So it's part of the config. If you now go back to user service, we can see that the error is gone and we should be good to go. Okay, now we have the user service, and now we want to register our very own user. So what I'm gonna do is I go back to the application, and you've seen me doing this before. I use a new bean because Spring Boot application is also configuration, so I can provide my own beans here. So I'm gonna say run, and I request the user service, and I'm just doing command line runner, and then register a new user. So we're gonna say users register. So we say hello@axgr.dev, and the password is just saltfish. And that should register a user that we can now use to log in. So let's actually start the application, see if that works. The application started successfully, as you can see. We're still getting that information, but you can see that the UUID that had been generated previously is no longer there. So I'm not going to the browser all the time, but just stay in the shell here. So I'm using HTTP, and now want to see if that still works. So we're going to users me. So this is the endpoint that we created, right? And you can see Spring Security is returning HTTP 401 if we don't provide any authentication details, which is correct. So it requests us to provide the basic authentication. So what I can do here is provide them in this format. So that's the username, and the password is thoughtfish. And let's see if that works. That works pretty nice. So this is the existing user that we have right now, right? This is the one that we register here. And you can see it just is used by Spring Security to, whenever there's a request that needs to be authenticated using basic authentication, it uses our user service to bring up the user, validates that the password matches using the password encoder. And you can see this is the user that we have just created. It has that username, has this authority, it has the password here, which is the hashed version. So this is why you never should expose a principal directly, because these information should never actually leave your backend. So basic authentication works. We have it customized. Next step is adding our very own filter configuration. So let's go over here, and then we call this one-time password auth filter. That implements the once per request filter. So this is important because there are no guarantees when it comes to these filters. They can be executed multiple times per request. We just want to make sure that our filter is just executed once, and this is why we have to extend once per request filter here. So now I have to implement the do filter internal function. Let me just clean that up slightly. So we have the request, and as you can see, since we're using Spring Boot 3+, this is the new namespace from Jakarta. And there we go, chain. Okay, what are we gonna do? Let's just add a logger here. We just want to confirm that this works. So I'm gonna say log equals logger factory get logger one-time password. That is correct. That's the logger. And what we're gonna do is we say log info filter invoked. And then we have to say chain do filter. So we have to forward the request. Once we're finished with our processing of the current request, we just delegate to the filter chain, and the next filter in the chain can do its work. So how do we know if this filter actually works? It doesn't until we register it. So I don't provide an annotation here, but I go back to our security config, and then we can register it ourselves. So I go to the bottom and I say add filter, not add, but add filter after. Because if you remember, I want to make sure that basic authentication always succeeds, and only then we come in with our filter. So what I'm going to do is pretty much what Copilot suggested here. Let me just verify that's correct. So we say add filter one-time password filter. We just have to import this. No, it's not, the name is not quite right. It's one-time password auth filter. So that should be correct, not filter. And we want this to be placed after the basic authentication filter. So now it's correct. So now if we, let's actually do this. Let's start the application and see how this works. If we are here, I want to see the request coming in. So let me just go to the terminal again. and we just execute the authentication again. And if I check the console, this is why we have tracing enabled for Spring Security. You can see this is the request that's coming in, and here we can see the security filter chain. So this is the current chain of filters that has been provided at runtime. And what I'm looking for is this one. You can see basic authentication filter is in there, as we can see, because we've been able to authenticate. And right after this, there's the one-time password auth filter that we just provided, and it's running behind that filter. And we can see here is a nice little log statement, which tells us that our filter indeed got executed. So we leave the filter for the time being. We just go back to it later. Let's first start building a few other components that Spring Security relies upon. The first one is what I call a one-time password. So this is the actual authentication attempt. What does it mean? So that's not an interface, that's a class. And we want to implement the authentication interface. Is that correct? That's the one. Let me check. Implement. Yes. So an implementation of authentication usually describes an authentication attempt that can later on be authenticated once it has all the authorities, etc. set. So initially, this is just the attempt. And now, again, I could just implement all these members here that you're seeing, but I'm lazy. I'm using Kotlin, which is one of the reasons. So I call this by initial, and I tell it, okay, we need an initial authentication, and we delegate. This is the same trick that I pulled when it came to the user details. Again, what I'm doing here is I'm expecting an initial authentication, which we have, which is the basic authentication. And then we just wrap the one-time password authentication on top of it. So what I can do here is now I'm just overriding one of the methods, which is get credentials, because the credentials in our case is the code. Oh, I don't have that. So of course we need the code here. Well, code. So this is the code that has been provided by the client, right? And this is the credential for one-time password authentication. Let's go back to our filter and see how we can use that. How does the actual filter do its work? So first of all, we want to make sure initial, there is something in the security context, and there's a security context holder actually, get context authentication. This is accessing the security context, and there should be the existing basic authentication. So we just use that and get it out of the security context because we want to get the username at the very least. So now I'm going to say, just to be extra secure here, I'm saying if initial is authenticated, only then we add the one-time password functionality on top. So what I'm going to use is a user, and for that I need the user service. So well, user service. So I'm going to look up the user here, users, and I'm using my by username function because it's a bit more convenient because I need the token user and not just the user details interface. So I'm saying users by username, initial name should be from the initial authentication, the username, which should be the email that we've set. And with the user, I can say if user requires MFA, only then we continue down this path. Yeah, so how do we get the code right now? So we have the request that's coming in here, and we now need to map the request to a one-time password. And one-time password is again the authentication that we just created. So how do we map from a request to one-time password? Well, that sounds like a job for a converter. So we build a one-time password converter. And this is implementing an authentication converter. And we have to implement convert, as you would expect. So making this non-nullable, as should be the case. So what we're going to do is the one-time password needs to be provided somehow, and I decided to provide it as part of a header. So if a user has to provide MFA credentials, these have to be provided in a dedicated header. So let's just make this a constant here. Private. Where is it? Private. Well, no, it's const first, right? Const OTP. Header name. Let's do this. So I call this OTP. So there has to be a header that's just named OTP, and it has to contain the code. That's what we're expecting here. So if we have that, we can say, okay, the one-time password is equal to request get header, and then we use our header name. So this should give us the code. But we just want to be sure if OTP is not is not provided, like it's null, or it's blank. That looks almost correct. But what we're doing here is something else. We just return null, because in our authentication can be converted here unsuccessfully, in which case it is allowed to be null, which is what we're doing. So we're returning null if the OTP is null or is blank, and otherwise we create a new one-time password and then pipe in the initial authentication and the one-time password. So we don't have the initial authentication here, so that means we have to provide it as part of the constructor private val initial authentication. And that should be good to go. So this is our converter that now converts based on an existing authentication. It can use the request and provide a one-time password. So let's go back to the filter. So we can go back to that check. If a user requires MFA, we say, okay, then let's get the one-time password. And I'm delegating to the one-time password converter and convert the request. So this has to be instantiated per request. Maybe there are ways to improve this, because that one-time password converter again needs the initial authentication object here. So that's the way I'm doing it today. And then we do the double check. If OTP is null, because this is now the authentication, or OTP code is blank. Where is it? Okay, it doesn't have the code. So let's go back here. Yeah, what I wanna return here is our one-time password, because that's an authentication, so I can return this. And in the filter, I can now say if the code is blank, then we got an issue, right? Because here we established that the user is authenticated and it requires MFA, but didn't provide a code the way we expect. Then we can say, okay, log info if we want, no OTP provided, and let's see if that's correct. Yeah, we set, yeah, two things. No, we don't send the error. What we're gonna do is we set the status to HTTP servlet response unauthorized. So from our point of view, the user is still unauthorized. But how does the client know, right? Because we have basic authentication and we have the one-time password authentication. So the client provided valid credentials, username, password for basic, but now we would return just the HTTP 401 unauthorized. The client wouldn't know what's wrong. Like, is the username wrong? Was the password wrong? No, it's actually the one-time password that's wrong, right? So we need a way to tell the client that only that part needs to be reconsidered or provided, whatever, right? So the basic credentials were correct. So the way we do this is by writing a header and doing set header here. And I call this, I'm using, yeah, that's pretty much what's suggested here. So I can use www-authenticate, which is also used in the context of asking for basic authentication. So I say this is OTP for one-time password. This is not a standard or agreed upon way of doing this, but it gets the job done. You are free to do this any way you like. You can even return a response in like a response body, which tells you, okay, this exact part is wrong. I'm just setting a header here. I'm using this, which is close enough to what's out there already. But again, you are free to do something else. So here we're just making sure that users have provided the code. And now, since we are here, what we can do is we say auth equals. Now I need the authentication manager. So authentication, where is it? Authentication manager. Because at this point we have the authentication object, and now we need to pass it on to, let's go back to the image here. So we have that authentication object. We need to pass it to the authentication manager, which then needs to look up the right provider to do the actual authentication logic. So I'm gonna say auth manager authenticate. So we pass in our OTP, which is the one-time password. We just expect this to work. So if it works, then we're gonna do this. We again get access to the security context, and then we say, okay, authentication is this one. And this may actually fail, like the manager may fail to find a provider, or the provider might throw an exception, as we see. So we have to catch this here. And this is usually an authentication exception, as you would also expect. And with that, we're gonna say, okay, response status equals HTTP, where is it? I have it here. Servlet response SC unauthorized. SC is for status code, so, and we just return here. And let's also make sure that we lock the other case. So this is in a case that we have a user that's successfully authenticated, but does not require MFA. So that's that. We can remove that lock statement. And that pretty much is all we have to do for the filter. So let's briefly recap what has happened. So we get the existing authentication from basic authentication. We make sure the user is authenticated. If that's the case, we check if the user requires multi-factor authentication. If that is the case, we convert the request to an authentication object that is still unauthenticated. That's important. And then down here, we just make sure, so once we have that authentication object, that we delegate to a manager, which then will delegate to a provider, etc. And this is what we now have to focus on. So let's go and start building the one-time password. That's a long name, I'm sorry for that. One-time password auth provider. And that's the component that's doing the actual authentication logic. So this has to implement authentication provider. And this also has to actually do it. So these are the two methods that I talked about before. Again, I make them non-nullable. This should all be safe to assume. So first one that is usually invoked is the supports. And we just want to make sure that we only handle authentications for one-time password requests. I can say one-time password class Java equals the authentication we are giving here. So this should make sure that whatever we have to authenticate here is an instance of one-time password. Let's do, well, auth. So we use the authentication and cast it to a one-time password, because again, this should make sure that we only get one-time passwords here. So I have the auth. Now I'm getting the user. Users don't have the user service yet. So let's get that private. Well, user service. Where is it? There we go. Now we say users by username, and this is the name of the authentication, right? The name is what has been provided, which is hello@xgrdev in our example. So that's a token user already. I don't need to cast that. And now we want to see if there's a device. So what I'm going to do is user device. So the user should have a device here. So this is just the check. If the user doesn't have a device, then we throw an exception here, because at this point we really expect them to have one. Otherwise, we shouldn't be invoked in any other case. So I can make sure if user requires MFA, which should be the case again, and if device accepts our auth credentials to string. Yeah, let's stop here in a second and I explain what I'm doing. Just finishing this off. Bad credentials exception. Yes. So we use the accepts function that we created on the one-time password device and path in the auth credentials. Again, auth is a one-time password and credentials are just the code, right? So what I'm saying is, does the device accept the code that has just been provided? And if it's not the case, we throw a bad credentials exception, which will be translated to another 401. And this is what we just took care of here. This will bubble up here and will be caught. So we just say, we just set the response status here and should be good. Now we have to still authenticate, but actually we're doing something boring here. I'm gonna do this. So we're not returning the one-time password authentication, which is now what we get in here is the unauthenticated authentication object, and we have to return the authenticated authentication object. So, but I'm just kind of flipping this on its head. What I'm doing is I return the initial authentication, which is the basic authentication, because that is already authenticated and it makes it easier, right? So I'm just taking care of the case that the one-time password is incorrect, and I'm throwing an exception and we go just all the way back and users have to provide a correct OTP. But if everything's fine, I just return the initial authentication, because the one-time password authentication is really just used as part of the authentication and it's not needed further down in the application, especially since the code changes pretty quickly. Here I can use component. So this is instantiated automatically. So let's see if we can actually run this. We didn't run the application for a few minutes now. So let me do this. And we can see we're seeing some errors. Okay, the first one is we don't have a value for users. Yes, that's correct. So our one-time password auth filter needs the user service. to look up users, right? So that's the first thing that we're gonna do. So we're gonna say users, and it still is missing the authentication manager. And this is something that's really tricky, and that took me a long time in preparation for this tutorial. At least in the current version of Spring that I'm using in Spring Security, it's not easy to get access of the authentication manager directly. So you have to just trust me on this one, on how to do this. So there's something that's called config, and it's not called this, it's an authentication config. Oh, where is it? Authentication configuration, that should be it. And that config has access to the authentication manager. So what I can do here is, let's actually, is it the first or the second parameter? Let me check. So we have user service and then the authentication manager. So I'm going to do config authentication manager. This is really weird. I don't know why it's that hard, but I tried other ways of generating and injecting it directly. It didn't work. So this is the only way I've made it work, by just injecting the authentication configuration here and then just grabbing the authentication manager that's in there. So now let's start the application again. Let's see if that works. That's compiling. That's always good. There we go. So let's go to the terminal and then see if we can access the user. So what does it say here? We're getting an HTTP 401, which is weird because that should still work, right? Because we have the user that we registered here. Where is it? And that user doesn't have an MFA device registered just yet. So for that user, it should still work. The reason why this no longer works is because the DAO authentication provider is no longer available. So if we go back to the image here, you can see still, this is the basic authentication flow on the side. And this is our filter. And basic authentication filter uses the authentication manager, which is using the DAO authentication provider, which is using the user service and the password encoder. We had that all the time, but we now lost it. And most likely the reason is because we provided our own authentication provider here. Since DAO authentication provider had been provided automatically, it got removed in favor of our authentication provider. What we can do still is we can add it back manually. And we need a few things for this. So I'm going here and I'm saying authentication provider, and I registered myself. I say DAO authentication provider. I say apply, which is a shorthand syntax to make changes to the existing instance. So I can say, yeah, pretty much what is suggested here. They got a lot easier with GitHub Copilot here. So I'm saying the user details service is our user service, and the password encoder is the encoder. So now we're adding that provider back in, and the authentication manager should now find it again if we restart the application. Let's see if that works. So let's back up. We go into the terminal and we try to log in, and there we go. It works again. We just had to provide that provider. So this looks good. So the basic flow is still working. And now we get to the final part, which is attaching an MFA device and then seeing that the flow works as expected. So let me stop the application, and then we go back to the user service because I want to have a convenience function for doing this. I call this fun attach and confirm device. So you can find a tutorial with all the steps and the code in the description down below. And usually for the device to be attached and confirmed, I would create a new controller, and you can find this in the source code. I'm not going to do this here. I just say attach and confirm. So I'm providing the username and I'm saying, okay, what is the name of the device and what is the secret? And that should return me the one-time password device because I can use it done going forward. So I'm going to say the user is, let me check if the code is correct. User, we get the user. We create a new Google Authenticator device with the secret, right? If we don't provide a secret, it's created at random. But here we're gonna but we provide our own secret. And I'm providing a fixed secret because it's easier to just generate codes. Otherwise, I would always have to import a new secret. So I'm using a predefined secret. And I would say, okay, the user device is the device. We don't need to confirm this because it's, we can confirm this here. This was missing. Confirmed equals true. That should be easier. And then we return the device. And now we go back to the application. And here we can say users attach and confirm device. So for this user, I'm using Google Authenticator as the name. And now the secret is, this is the secret. So this is the secret that I had created previously because I want to, as I said, I keep it static so I can easily import it. And that should now require us to provide one-time password code. So let's see if I save this, restart the application, go back to the terminal, close this window. So if I now do the same thing, I just use basic authentication here to access users/me. It says, oh, you're unauthorized. And you can see here's the HTTP header. It says www-authenticate OTP. So that means, oh, okay, basic authentication has worked, but I have to provide a one-time password. So how can I do this? We're just doing the same request. And now we have to say OTP colon. That's, again, I'm using HTTP, and OTP colon defines a header. So now I have to be really quick because I have a 2FA application running here. So this is a service where I imported the key. Let's see if I'm fast enough. This is the current code I provided here. Let's go. And it worked just like that. So you can see I provided the correct code, and we can try with an invalid code as well in a second. But you can see it's returning again the user details. You can also see that this is the device that has been attached. Again, all this information shouldn't be part of a production setup. So if I now change the code to something like 5, you can see that it says this is wrong again, right? So this is unauthorized because the code is invalid. And that pretty much wraps it up. And I think we covered a lot of ground today. So let me go quickly back to the image what we've did. So we set up basic authentication to work with our own user service and a password encoder. And then on top of that, we used our own one-time password filter machinery that would delegate to the same authentication manager, and then would just make sure that we register our own authentication provider that would implement the actual logic for making sure that a one-time password matches. So the final part that's left you can find in my previous video. If you want to just generate the QR code, you can now generate that per user. So each user can just scan the QR code, get the secret and have it in their app so they can start using their one-time passwords going forward. I hope this has answered all the questions that you had. If there's anything missing or if you have any questions, just drop them in the comments down below. Thanks for watching and I'll see you in the next one.